Guys, let us look at this particular example. Now, in this example, we want to find the equation, or we want to write the equation of a tangent line given an equation and given a point. So we want to write this equation for x equals to pi over 3. Again, guys, we need few things in order to actually write the final answer for this one. We need to know the equation of a line, and the equation of a line that I'm going to prefer, or I'm going to use here, is the point slope form, which is y minus y1 equals to m. In this case, I'm going to say m of the tangent line, slope of the tangent line, m subscripts of tangent, and then I have x minus x1. So guys, I already have my value for x, which is pi over 3. Now it's up to you how you want to actually do that. Guys, there's one thing I want to tell you about this particular problem is like we don't want to get the final, like we don't want to write any of the points or any of these things in decimals. We want to keep things in radicals. If we can simplify those radicals, then one must simplify them. Otherwise, we want to keep everything in radicals. So in order to keep everything in radicals, one has to be a little careful here while evaluating any of these things. So first of all, guys, if x is pi over 3, that means my x1 is pi over 3. And then I want to evaluate, or first of all, I want to calculate the corresponding y value, which is the y1. In order to get that y1, all I have to do is I have to substitute pi over 3 for x here as well as here, and I have to evaluate or simplify this, and whatever I get is going to be my y1. So there's like, guys, you cannot directly do it on a calculator because the calculator may give you a decimal value. We want the radical values. So there's few things you can do. One, you can just look at the unit circle if you have a unit circle with you, or you can just look it up. The other thing is one can draw a special triangle, because pi over 3 is actually 60 degrees, right? So it is equal to 60 degrees. I try to do that just for me, to make it easier for me sometimes when I'm actually drawing the special triangles. Guys, if you do not remember the special triangles and all that, then you can look at the unit circle. Otherwise, we can also we can also draw special triangles. Guys, for me personally, when I learned this stuff, we were not allowed to use the unit circle or any of those formula sheets. So one had to remember other ways of kind of evaluating these things. So I always remember the special triangle, which is the 30, 60, 90 triangle. Guys, this is my if I think of this as a 60 and this will be 30, that's fine, we know that is 30, and this is my 90 triangle. And I know the ratios are like radical 3, that is my opposite, and which is opposite to 60 degrees, and then my hypotenuse is 2, and this length, this adjacent, is 1. That is something I remember, or one should remember for the special 60, 30, 60, 90 triangle. So from there, guys, I should be able to, I mean, of course, I still have to know what is the sine and what is the cosine, what are the ratios, what are the formulas for those, which is not too complicated. You have to just remember the SOHCAHTOA, right? Sine is opposite over hypotenuse, and cosine is like adjacent over hypotenuse, and so on. So guys, to evaluate that y1, I'm going to substitute x equals to pi over 3 here. So it's going to be 3 times tangent of pi over 3, and then minus 2 times cosecant of pi over 3. Now, again, you can look at a unit circle, or you can just look at this, draw this special triangle for your reference, and you can evaluate the tangent and the cosecant. So tangent of pi over 3, which means tangent of 60, would be, we know the tangent is opposite over adjacent, so it is just times radical 3 over 1. I don't have to write that 1. That is good enough. Minus 2 times cosecant. Guys, cosecant is the reciprocal of sine. If sine is opposite over hypotenuse, then cosecant would be hypotenuse over the opposite. So what is hypotenuse? 2, and the opposite is radical 3. So it would be times 2 over radical 3. Let us simplify this. This is 3 radical 3. Guys, keep in mind, we are not trying to simplify radicals. I mean, if we can, then we should, but in this case, radical 3 cannot be simplified any further, and we don't want to leave the final answers in decimals. So that's why if it's radical, we got to leave it in a radical. And that is in the first place why we actually have to do all this, drawing the reference triangle or looking at the unit circle. Otherwise, you can use a calculator if you're allowed to use one, and you can get the actual value, like it would be a decimal. Minus 2 times 2 is 4 over radical 3. Guys, usually we don't like to have radicals in the denominator, so it's up to you whether you want to like rationalize this, like multiply. Let us actually do that here. We can multiply this by radical 3 and radical 3, so that would be, let us see what we get then. Finally, what I get here is 3 radical 3 minus 4 radical 3 over radical 3 times radical 3 is 3. So guys, we can finally like leave it like this. We cannot simplify any further, so we can leave it like this. That's my y1, so let me write that y1. So x1 is pi over 3 and my y1 is 3 radical 3 minus 4 radical 3 over 3. Guys, this is my x1 and y1. Good. Now all I need is to find the slope, and we know the slope is the derivative of this function, right, at that particular point. So to find the slope of this equation, we have to find the derivative of this function, and then we have to evaluate that derivative at a point x equals to pi over 3. That is not too difficult to do because we already know the derivative of the trig function. So let us go ahead and set that up. So guys, y prime, the derivative of this function is 3. And we know the derivative of the tangent function is the secant square of x. So it's going to be 3 times secant square x minus 2 times, what is the derivative of the cosecant x? Guys, if you remember, that's great. And I suggest that you should try to remember those. Otherwise, there's two things, guys. You can go back and look at the formula sheet if you're allowed to look at the formula sheet, or if you remember, and you should remember the derivative of sine and cosine. If you remember the derivative of sine and cosine, you should be able to evaluate the derivative of rest of the other trig functions. So if I know the derivative of the sine, I should be able to get the derivative of the cosecant. Of course, I have to use either the chain rule, or I have to use the quotient rule. So in any case, guys, I remember the derivative of the cosecant x because I have been like using this all the time. So I'm going to write the derivative, which is negative cosecant x and cotangent x. Don't forget there's a negative here. And that is it. We are done with the derivative. Let us write it out clearly. So y prime is 3 secant square x. Negative times negative is positive 2 cosecant x and cotangent x. Guys, this is the derivative of the function. But we want to find the slope, which is going to be a number. We got to evaluate this derivative at what point? X equal to pi over 3. That point is already provided to us. So let us go ahead and substitute that and see what we get for the slope. M, which is what we are evaluating now, is the slope. And that is the y prime evaluated at x equal to pi thirds. And we have to substitute x equal to pi thirds. And then we may have to again go back either to the unit circle, or we can just go back to our reference triangle again. Now it is 3 times secant square pi over 3 plus 2 times. So guys, the other thing that I want to tell you already is like, and that is something I always like to do. Guys, I don't work that well with the radian measures, okay, for some reason. So what I do right away whenever I have to deal with the radian angles and radians, I convert them directly to a degree measure, and then life becomes easier for me. If you are comfortable working with the actual radian angles and you can figure things out, that's fine, you can use that. Otherwise, guys, my suggestion is convert this angle into a degrees. You know, you just have to multiply by 180 over pi, pi is cross out, 180 over 3 is 60. And then life becomes a little easier for me. So it's 2 times the cosecant of pi over 3 times the cotangent of pi over 3. I think we need more room for this. So guys, I'm going to make more room, and then we are going to evaluate the slope, okay? So this is all done. So let us let me try and squeeze in this whole thing here. Let's see how far we can get with this. So 3 times, okay, secant square pi over 3, which means we have to first evaluate the secant of 60 degrees, and then we got to square it. Now I know the secant is the reciprocal of the cosine. Cosine is adjacent over hypotenuse. So secant would be hypotenuse over adjacent. So that would be hypotenuse is 2, adjacent is 1. So let me label these things. This is this is hypotenuse, this is adjacent, and this is the opposite. If this is my reference angle, and 60 degrees is my reference angle here. So secant of 60 is going to be 2 divided by 1, hypotenuse over adjacent. So I don't have to write divided by 1. I just write 2, and I have to square it. Don't forget there's a square. So I got to square that, then plus 2 times, let us see what we have here with the second piece, 2 times cosecant of pi over 3. Guys, cosecant of pi over 3, we had already calculated that in the previous, when we were calculating the y1, but let us go back and again revisit that. Cosecant is the reciprocal of the sine. If sine is opposite over hypotenuse, the cosecant will be hypotenuse over opposite, which is 2 over radical 3. So it is 2 over radical 3, right, for the cosecant, and then times the cotangent. Cotangent is the reciprocal of the tangent. So tangent is opposite over adjacent, so the cotangent would be adjacent over opposite, which means it is going to be 1 over radical 3. So everything kind of worked out well. We don't have to try to rationalize anything because the radical 3 times radical 3 is eventually going to become just a positive 3. So let us simplify this. 2 squared is 4, 4 times 3 is 12. So it is 12 plus 2 times 2 is 2 times 2 times 1. So 2 times 2 is 4, 4 times 1 is just 4. And radical 3 times radical 3 is just 3. So you can let us, yeah, we should try to combine them. So combining them is not too difficult. We want to have a 3 here times 3 here, a common denominator. 12 times 3 is 36, 36 times plus 4 is 40. So it is 40 over 3. That is my slope. Guys, we have everything that we need. Let us go back and write the final equation. And here is where I'm going to write the final equation. Guys, the final equation is going to look like this. Put it in the box. Y minus y1. This whole thing is my y1 or whatever it is. Guys, I'm going to write it. And let me put it in parentheses. 3 radical 3 minus 4 radical 3 over 3. Okay. If you want, you can combine them, simplify them, or you can leave it like this. No big deal, guys. Equal. Again, it depends on what is the final answer. If you're trying to match it with the answer in your textbook, then you have to see like if they want to simplify further. So then you have to simplify further. Or equals to the slope 40 over 3. And then what do I have? X minus x1, which is x minus pi over 3. Guys, you can leave the final answer like this, which is totally fine. Or if you want to just solve explicitly for y, then you got to bring this to the other side, and then you will have the equation in the y equals to mx plus b form. Okay, guys, this is the whole process of writing an equation of a line. In this case, again, it's not too complicated, and we have already seen a lot of these examples where one has to write the equation of a tangent line given a function, given a point. But in this case, one had to be a little bit more careful with using that point and then evaluating the corresponding y1. One may have to use the unit circle or draw a reference triangle for reference, and then you got to substitute values, and finally we have the equation of the line. So guys, this is example 4. I have been trying to show you many different variety of examples in this section. So keep trying, keep practicing these, and I will see you in the next video with number 5. Okay, till then, take care.